Chapter 12 Static Equilibrium. We say that a rigid body is in equilibrium when both its linear and angular acceleration are zero relative to an inertial frame of reference. This means that a body in equilibrium can be moving, but if so, its linear and angular velocities must be constant. It states that a rigid body is in a static equilibrium when it is at rest in our selected frame of reference. Conditions for static equilibrium. The first equilibrium condition for the static equilibrium of a rigid body expresses translational equilibrium. The equilibrium condition for forces is that the sum of all external forces acting on the body is zero. The second equilibrium condition for the static equilibrium of a rigid body expresses rotational equilibrium, in which all external torques from external forces are zero. If one of them is not satisfied, the body is not in equilibrium. In many equilibrium situations, one of the forces acting on the body is its weight. In free body diagrams, the weight vector is attached to the center of gravity of the body. For all practical purposes, the center of gravity is identical to the center of mass. The gravitational torque is the torque on the body caused by its weight. It occurs when the center of gravity of the body is not located on the axis of rotation.